And so try to na in when we are solving some numerical and we are solving some problem, so
Yeah.
make sure that just try to apply your mind. Okay.
Mm.
So different person will solve the question in different way.
Yeah.
Okay. So you have to choose your own way. Okay. So okay, but remember the basic fundamental will remain same. Like I am saying that
Okay.
Coulomb's law remains same. Gravitational force remains same. Newton's law of gravity remains same. Yeah, things will remain same, but you have to try it. You have to try to solve the question like that. You are solving the question and you are sitting in an examination hall. Always remember this point. Whenever any question I am giving on any question I am solving, suppose I am just teaching to any student, so I always think that there is my exam and I am sitting in the examination hall and I have a limited time. Okay.
Mm.
So always remember, when you are solving any problem, remember that time is very important. Time.
Yeah.
So keep in mind, when we are solving any problem, the time plays very important role. Okay. So one by one we will solve the question. This question we have completed. Now we will solve this question. Well, very easy questions. These are okay. So as you have told me that we have 30 minutes. Okay. So you can remind me when time is over. Okay.
Yeah. Yeah. Okay.
Uh, Okay. So just wait. Okay. So I am taking this question and we have to solve this question. So I need some distance. Okay. This is the question we have, and so basically the thing is that in examination you will be in the examination. Means I will be not there. So basically that is why I am saying I can just make you understand how to solve. But at the end of the day, you have to solve the question. Okay.
Yeah.
So, huh. So now see this question. Uh, in this question, it is given that a car travels 100 kilometer. A
Mm.
car travel 100 kilometer. The journey takes 2 hours. The journey takes 2 hours, and the highest speed of the car is 80 kilometer per hour. Okay, the highest means this speed. Highest speed is this, and the lowest speed is this. And they are asking the average speed. They are asking average speed of the journey.
Mm.
So when you are solving this question, so we know I can solve this question in 1 or 2 seconds also, because I know the formula. Average speed is equal to the total distance divided by total time. Okay, total distance divided by total time. But here the thing is that we have to understand what we have to get a feel of the question. Okay, so basically just I will draw the figure. Okay, there is no requirement of figure. Okay,
Yeah.
without the figure also we can just solve this question.
Mm.
Just wait. What happened? Hmm. So this is the question. Why this is not working? Okay. So basically, the car is moving from here to here. 100 km is the distance traveled,
Mm.
and for this journey, time taken by the car is 2 hours.
Yeah.
Time taken by the car is 2 hours.
Yes.
Basically, the car is started from A, and finally the car is reached at point B and covered the 100 km. And simple. Uh, this data is the extra, you can say.
Okay.
Okay, so basically, sorry, I have not shared my screen. So basically, this data is the extra. Okay, so Rayyan, I have just started the focus mode. Okay, you can just now open your video. Okay, I have started the focus mode. Okay, fine.
Mm.
Now see, simply we know that average speed
Mm.
is equal to the total distance divided by total time. What is the total distance covered by the car? 100 km.
Yeah.
Divided by total time is 2 hours.
Yeah.
So the answer will be 50 kilometer per hour.
Okay.
50 kilometer per hour. And there is one more thing that I want to tell you. If you want to convert kilometer per hour into meter per second, so what you have to do? This is 50. This is kilometer per hour. Okay, and you want to convert this into meter per second. So what you will do? You will multiply with 5 by 18.
Mm.
Okay, so why we are multiplying with 5 by 18? Uh, because this is 50 kilometer. Okay, take 36 kilometer. That
Mm.
will be okay. We are take 36 kilometer per hour is the speed, and I want to convert this into meter per second. Okay,
Mm.
this is going to help you a lot. So in 1 kilometer we have 1,000 meter,
Mm.
and in 1 hour we have to convert 1 hour into seconds. So it will be 60 into 60 seconds. Okay,
Yeah.
so finally when you will cancel this with this and this with this, it will become 10, and in denominator it will be 36. So it will be 36 into 5 by 18. So remember, this the factor 5 by 18 you have to multiply.
Mm.
So what will be the answer? 18 to the, so 10 meter per second. Okay, so in this way you can convert. This is basically a short trick. If suppose I am saying 54 kilometer per hour is given and I want to convert it into meter per second, so what I will do? I will just multiply it by 5 by 18. So it will become 15 meter per second. This is another question. This is the another question. Very simple. They are saying which is an example of weight is an example of the quantity.
Mm.
Can you tell me the answer?
Mass.
Okay, mass. You have to tell this. So basically now I also don't know what is the weight. So I will check from the formula of the weight. Basically, weight is mass into gravity or gravitational field G.
Mm.
So now we will see from the unit. Okay, we will see from the unit. What is the unit of the mass? Kg.
Yeah.
What is the unit of gravitational field? Force per unit mass,
Yeah.
means force divided by kg. So kg and kg will be cancelled out.
Mm.
So basically, oh, just a minute, just a minute. We have done a mistake. Mm, okay, so how to solve this question? Suppose if you, I know the answer is B. Okay, the
Mm.
answer is B, but I am telling how the answer is B. Okay, so write the unit of mass first. You know weight is equal to mass into G. Write the unit of mass. Unit of mass is kg. And unit of G, what is G? G is the gravitational field, or gravitational field formula is gravitational field is basically force divided by mass. Okay, gravitational field is force divided by, you now write the unit of force. Unit of force is Newton, and unit of mass is kg. So kg and kg will be cancelling out. So basically the weight has a unit of Newton, and Newton is a unit of force. So basically weight is a force. And why weight is a force? Because I have told you weight is a gravitational force. So B option will be correct here. Okay.
Yeah.
I have told you, na, weight is the force. Weight is a gravitational force on the body.
Mm.
So basically, this is the earth. What is weight basically? This is the earth. This is suppose any object. So the amount of force, that is gravitational force acting on the this body, is equal to the weight. And basically weight is a force. Okay. So answer B will be correct. This is the mass measured on the object, mass of the measured speed of the one. So this is very easy question. So we will solve this question now. Just tell me which statement about the mass of the weight is correct. First.
Uh, weight is a force.
Right. Weight is a force. And mass is a force? No, mass is not a force. Mass is mass. Mass is measured in Newton? No. Mass is measured in kg. Weight is a force? Yes, of course. Weight is a gravitational force acting on the body by the earth. Weight is measured in kilogram?
Yeah.
No.
No.
Weight is measured in Newton. Okay. Question number 7. What is the weight of an object? What is the weight of an object? Just read the option and try to figure out the answer.
The force of gravity on the object.
Right?
Yeah.
You know that force, gravitational force or gravity force on the object. The gravitational potential energy, no. Internal energy, no. This is also no.
Mm.
Now here is a question for this. Basically, which instrument is used to compare the masses of the object? I have taken some of the figures here for explanation of this question. Okay, so we are solving this question. Okay, so now see this question. In this question, they are saying which instrument is used to measure the weight of the which instrument is used to measure the masses of the object.
Balance.
Basically, huh?
Balance.
Balance. You are right. Basically, this is a balance. Have you seen this balance? We have seen this balance in the shops and there,
Yeah.
na? So
Yeah.
this is a balance. So basically, balance is used to. So balance is used to measure the. This is the answer. But I am telling you what is barometer, what is manometer, what is measuring cylinder.
Yeah.
Basically, barometer is a device used to measure the pressure. Manometer is also a device used to measure the pressure.
Mm.
Okay, but a measuring cylinder is this. So in
Yeah.
in laboratory, if you have seen the measuring cylinder, we take some liquid in the measuring cylinder and we measure the volume. So
Yeah.
what is the work of the measuring cylinder? To measure the volume. So
Yeah.
here I am writing this balance, is used to compare the masses. So what is the use of the barometer? So basically, barometer is used to measure atmospheric pressure.
Mm.
Pressure. And another thing given, manometer.
Mm.
So basically, manometer is a device used to measure the fluid pressure.
Okay.
So this is a device used to measure fluid. Fluid means liquid. Liquid is a fluid.
Yeah.
Gas is a fluid or not?
It comes in both forms.
No. Gas is a fluid.
Mm.
Gas is a fluid.
Yeah.
Okay. So used to measure fluid pressure. And after this, a measuring cylinder. This is a measuring cylinder. So you know what is the use of the measuring cylinder?
Yeah.
To measure the volume.
Yeah.
To measure volume. Okay, so next question. This question I think we have completed now. Okay, so they are saying basically this is a good question. So here they are saying a customer goes to a market and buys some rice. Simple. After that they are saying the stall holder pours rice into a dish. So basically there will be a dish, and in which the shopkeeper, you can say, pouring the rice.
Yeah.
And after that hangs from a spring balance. After that the dish hangs from a spring balance. So basically this is a spring balance. Okay. This is a spring balance. Inside the spring balance, these are rice, and this whole thing is a dish. Okay. He records the reading on the spring balance. He records the reading on the spring balance. So, so there will be some reading on the spring balance, obviously. Okay.
Yeah.
Okay. After that, they are saying the customer then buys some pasta. After the rice, the customer buys some pasta, and the stall holder notices that the reading on the spring balance with just pasta in the dish. Just pasta means with only pasta in the dish is same as that with the just rice in the dish. So after that they are asking the rice and the pasta must have. I know the answer. Answer will be the weight, but I want to tell you the reason behind why the answer is weight. So basically, what is the working of spring balance? You should know how a spring balance works. So what is the logic behind the spring balance? So this is a spring. Okay. What is this? This is a spring. Have you seen spring?
Yeah.
Okay. We can stretch the spring. We can compress the spring.
Yeah.
So what happens in a spring when you stretch the spring? So in spring there is a restoring force developed. There is a restoring force developed, and when you compress the spring from the normal position, then also there is a restoring force develops. Okay, so now this is the case. Okay, so so basically here is one spring, this, okay, and this is like this. This is the spring like this. This is the spring. Okay, this is the normal length of the spring. Okay.
Yeah. Okay.
This is the normal condition of the spring. No stretch, no compression. There is no stretch and no compression. So there will be no force, no restoring force in the spring. What happens after that? After that, suppose a weight is attached to this spring. So what will happen? The spring will stretch to some length.
Yeah.
Okay, here a weight is attached. Here a mass is attached like this, and this is the extension x in the string. Suppose this extension is x. Small x is the extension. Okay, this is the extension. So what happens now in case of this spring? Now this is the condition of the string. This spring is in the stretched condition. So if this string is in the stretched condition, so there will be force on this mass, gravitational force, that is weight of this mass, mg in downward direction.
Yeah.
But in case of in this spring, there is a force that is known as the spring force,
Mm.
and that spring force will be opposite to the weight in this case, and that spring force is basically spring constant K and the elongation X.
Mm. Okay.
K is the spring constant. K
Okay.
is the spring constant,
Mm.
and X is the elongation. It can be elongation or it can be compression also. So you can say elongation or compression. Okay. So now after a certain period of time, both force become equal. Both force become equal. So you can say that this weight. What is mg? What is mg? Mg is basically the weight.
Mm.
This weight of the object become equal to k into x.
Mm.
Now this reading, this x reading, you can read from the balance.
Mm.
Okay, you can read what is the extension, extension in the spring for, okay, from the balance. This reading will, you have this reading. So with the help of this reading, when you will multiply with spring constant kx, means you will get the weight of the body. You will get the weight of the mass m or body. So in this is the way the spring balance works. Okay, basically x will be the reading on the, okay, but here this is in the circular form, so somehow the reading can be in circular form also. So this is a basic thing I have just told you, how the spring balances work. Okay, so basically what happens in a spring balance, when you are measuring a weight, so weight of that body becomes equal to the restoring force of the spring. Basically fs here is the
Mm.
restoring force, restoring, or this is also known as the spring force.
Mm.
Okay, so basically spring balance measure the weight in this way. So answer is clear already. The weight will be same. If spring balance is, you can just try to imagine, spring balance is say, showing the same reading, so weight of the object will be k into x in case of the spring balance. So if the
Yeah.
spring balance is same, then spring constant will remain same, and they are saying reading of balance is also same. So it means the weight of the rice and the pasta will be same. Weight will be same.
Mm.
So the answer will be weight.
Okay.
So how much time we have?
We still have some time until
Hmm?
like
10
say,
minutes.
but maybe more. I think we
Okay.
might be able to do the whole class.
So got it now how the spring balance works. So this question is
Yeah.
okay. After that, just try this question. Just a minute. Basically, solving question will improve your thinking ability.
Mm.
So that is what is required. Okay, so try to solve this question. Answer is obvious, but we have to just yeah,
They have the same weight.
of course the answer is same.
Mm.
But I want to tell you how the answer is same. They are saying 1 kg sample of aluminium is stored in a laboratory, and in a different laboratory in the same town there is a 1 kg sample of iron. So here basically iron 1 kg, okay, and this iron in some another laboratory, and here is 1 kg aluminium.
Mm.
So this is 1 kg aluminium. and both are in different laboratories. Suppose this is the laboratory L1, this is the laboratory L2.
Mm.
Which quantity must these two samples always have in common? Now they are saying first option is density.
Mm.
So just tell me how density cannot be same. Can you explain how, if I am asking why option A is incorrect?
What is this, like, what is density, like the like uh
Okay, I am telling why. Density will be always different. Why? Because density is a property of a material. Like DNA, you know DNA.
yeah,
Every human have different DNA.
yeah,
So in the same way, different material have different density. So that is why density is not the correct option. Why?
yeah,
Because density is the property of the material. Same temperature. So suppose this laboratory is somewhere in USA,
yeah,
and this laboratory is somewhere in Qatar and in Middle East country, like warm countries. So temperature may not be same.
mm.
Temperature cannot be always. They are saying which thing is always same. Suppose I have placed uh, this lab. I have the lab number 1 in America and this lab in the Qatar. So temperature will be temperature. There will be temperature difference. Okay.
Yeah,
Of course. So this option is also incorrect. Same volume.
yeah,
Basically, we cannot say the volume is same. Okay.
mm.
Because there is no information given so that we can say the same volume.
Mm.
Okay, so this option is also correct. Basically volume is basically density. There is a relation between the density.
Mm.
Density is equal to mass divided by volume.
Okay.
Now see, so from here, if you are calculating volume, suppose V is the volume, M is the mass, and D is the density.
Mm.
So from here, if you are calculating volume, so volume is equal to density divided by mass.
Yeah,
Oh, sorry, mass divided by density. So this is mass divided by density. Is it right or not? So mass is same, 1 kg, and this is also 1 kg. So mass is same, but densities will be different.
mm.
Both the samples will have the different densities. So if density will be different, then and volume is depending upon the density.
Mm.
Volume is depending upon the density. So you cannot say the volume will also be different. Okay.
Okay.
Now weight. What is weight? What is the definition of the weight? Weight is equal to the mass into gravity or gravitational field.
Yeah,
Gravitational field. Gravitational field is strength, you can write. And we know that these masses are on the earth only, na?
yeah,
Not on some different planet, like this mass is on Mars, Mars is on
yeah,
Pluto and other planets. So mass is 1 kg of both. And
yeah,
on earth, what is the gravitational is 9.8 we take on earth.
yeah.
Okay. So on earth we have to take. See the logic behind this question. I can do like this also. This option is correct. But that is not the way to solve the question. Means in examination you can just do in a very fast manner. But when something I am explaining to you, so I always try make you understand in a proper manner. So basically, one is the mass is same for both the okay, uh, and 9.8 is the gravitational field intensity on Earth. So basically, both have the weight of 9.8 Newton. Okay. So suppose W1 is the weight of the iron, so it will be the mass of the iron, 1 into 9.8. So weight will be 9.8, and W2 is the weight of the aluminium, so it will be 1 into 9.8, uh, and it will be again 9.8 Newton. And this is for aluminium, this is for iron. Basically, this is for iron, this is for aluminium.
Mm.
Okay. So now this question, try to solve this question. This is based on the spring balance.
D.
D.
Yeah.
Okay, let's check. So basically, two blocks are there. One block is this, another block is this, and two blocks of metal X and Y from hang from the spring. Okay, hang from the spring as shown in diagram. First option, which what does the diagram show about X and Y? Because now you can see here reading is same.
Mm.
3 reading is 3 here, and here is also the reading is 3. So you can say the extension in the spring is same.
Mm.
This reading is 3 here, so X is equal to 3, you can say. Here also the reading is same, so X is equal to 3, you can say. Okay, so basically this reading is same here, and if reading is same, so I can say that weight of X is equal to spring constant K
Mm.
into the reading we are getting. So K into X, and weight of Y is also again K into X. Okay.
Mm.
Uh, so basically weight will be same, no doubt. Okay. Weight will be same.
Mm.
Okay. If this reading is same, here the reading of the spring balance is same. So you can say the weight is same. So, but what can I say about the mass? Okay, what can I say about the mass? Okay, so mass will also be same. How the mass will be same? Uh, See, basically weight of X is equal to the reading in the spring balance. Here is this Newton written, na?
Yeah.
Newton. So basically 3 Newton is reading. So weight of X is 3 Newton.
Okay.
And weight of Y is also 3 Newton. You can see reading is given in Newton. This N is representing Newton.
Mm.
Now weight of X means both have the same weight. This is clear. Now talking about the mass. What is weight? Weight is equal to mass of X into gravity is equal to 3 Newton. Mass of Y into gravity is equal to 3 Newton. Why I am taking G same, because both the masses are on the earth. Okay. So now if you will calculate mass of X, that will be 3 G, and mass of Y, that also will be 3 G. So we can say na weight is also same and mass is also same.
Yeah.
So, but what about the volume? So volume is basically mass divided by density. So mass is same,
Mm.
but can you say surely that X and Y have the same density?
Mm. No.
No, we cannot say, because these materials can be different. Okay.
Yeah.
So basically, what will be the answer now? They have the same mass and the same volume. but different weights. This is wrong. They have the same mass and the same weight but different volume. This is correct. Basically, option B will be correct. Okay. So this is also incorrect. This is also incorrect. Volume will be same when mass and density will be same. Okay, so just see this question. If you want to go, then you can tell me. Okay, I can
Yeah.
leave the class. So see this question. A student stand with both feet on some scale. Okay, some scale to measure his weights. The reading on the scale is 500 Newton. Okay, he lifts 1 foot off and the scale 1 foot off the scale and keeps it lifted. What is the new reading on the scale? Basically, there is some scale. Okay, and reading of the scale is 500 Newton,
Mm.
and that scale is used to measure the weight. Basically, suppose this is some platform or on which that this is the student. Okay, and and there can be any scale inbuilt to this. Okay, to this device having a scale. This time this boy is standing with both feet on the 1 feet and 2 feet on the scale like this. Okay, and weight of the boy is come out to be 500 Newton. After that, what happens? This boy lift one of its foot. So now this boy is on the weighing scale, and this time another feet is like this. Okay, this is another feet this time. Okay, so we have to tell whether this time the weight will be same or not. So what is weight basically? Weight is the mass of the boy. Weight is basically the mass of the boy into the gravitational field, or you can say, weight will be the gravitational force acting on the boy. So will the gravitational force acting on the boy will change when he lifts his foot? No, there will be no change. Huh? So in this case also, the weight will be 500 Newton. There will be no change. Why? Because weight is basically the gravitational force acting on the boy due to earth. So that will not change. Okay. So basically, answer will be C in this case. Okay. This question. See this question. They are saying a child sits on the rubber ball and bounces up and down on the ground. What stays the same when the ball hits the ground? The acceleration of the ball, the mass of the ball, the shape of the ball, the velocity of the ball. The simple answer B. Mass of the ball will never change. Acceleration.
It will change.
Acceleration basically
like how far up he's jumping.
Yeah. Shape of the ball, this cannot be correct. I am sure about this. Velocity of the ball, sure about this. This will definitely change. Acceleration of the ball, This will also be changed. Acceleration will also be changed. Okay. Because why the acceleration will change? If I am talking about for the acceleration, there will be the air resistance. So due to that, the acceleration will change. So this option will also not correct. So last question, I think. Just try to solve this.
B, mass decreases and weight stays the same.
What you are saying? Wait, which option?
B.
Option number B. Okay. So they are saying a cup contains hot liquid. Some of the liquid evaporates. What happens to the mass and to the weight of the liquid? So basically, this is very simple question. Suppose this is a cup, and there is a liquid in this cup. Okay, so this is the level of the liquid initially, and after the evaporation, there will be less liquid.
Yeah.
Because some liquid will be evaporate. Yeah. So basically, this part will remain empty. Okay, this part. So, so mass will increase or decrease? Decrease. So mass will decrease. So mass will decrease. Okay. So what is the option? Mass will decrease. And weight will. Or what is weight? Weight is equal to mass into gravitational acceleration or gravitational field. So if mass is changing, then you can say weight is also changing. Yeah. So mass is decreasing, and this is the constant sum. So this is the answer. Yes. Okay. Okay. So if you want to go, then you can go. No problem. I think I can leave in like 2 minutes. Fine. In 2 minutes. So got it now? How the mass will decrease because some of the part of the liquid will evaporate. So option A will be correct. We can do the last question, then I can go. Okay, this question also. This is also very simple question. So they are saying a geologist places a small rock on the left hand of pen of a balance. The two pens are level as shown. Okay, level as shown. This is the rock and this is the mass. So basically, this is a balance. Okay, and what is the use of the balance? To compare the masses. And if this pointer is here at 0, means the mass of the rock is equal to the mass of the this mass. Mass of the rock is equal to the this mass. Okay, so basically two pens are labeled as shown when the masses a total weight of 23 Newton are placed on the right hand pen. So what is the right? This is the right hand pen. Yeah. Right hand pen. Okay. This is right hand pen, and this right hand pen have the weight is equal to 23 Newton. Okay. Because these masses have total weight of 23 Newton. Yeah. Take the weight of 1 kg to be 10 Newton. This is given for 1 kg mass, weight will be 10 Newton. They are asking what is the mass of the small rock. P 2.3. Of course, answer is right. Very easy question. Basically, it is given that weight of 1 kg is equal to 10 Newton. So basically, this is given as on 1 kg, there will be a force of 10 Newton. and the force on 1 kg mass is the gravitational field. Gravitational field is 10 Newton. So, okay, gravitational field is 10 Newton. So basically, mass of rock will be equal to the this mass. Okay. So mass of rock is equal to the, suppose this mass is m. This is equal to m. So both masses are equal. So we can say that weight will also equal. Okay. So weight of the rock is equal to weight of this mass. So weight of the rock is equal to weight of mass is equal to 23 Newton. So answer will be C. Okay. So weight of the rock is equal to 23 Newton.
Okay.
Got it?
Yeah.
So in this way you have to solve the question. Okay. So this is the answer 23 k. Oh, 23 kg. Oh, just a minute. Just a minute. Just a minute. Sorry. 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 Your answer is right. Basically, they are asking the mass. They are asking. Okay. So weight of this mass, weight of the mass is 23. So this is mass into g is equal to 23. So from here g is 10. So mass is equal to 2.3 kg. And as the balance is showing 0, here this pointer is 0. So mass of the rock is equal to this mass. So basically mass of the rock is this mass, that is 2.3 kg. Right answer.
Okay.
And sorry for that. So I was thinking that they are asking. Wait.
Okay.
Any doubt you have, you want to ask?
No, no. I understand.